Hi guys, today we are going to learn about the static routing. So we all know about static routing, right? So we know the basic how to configure the basic IP addressing, right? Did anyone having the doubts to configure the basic configuration, which includes basic configurations, right? The basic configuration, which includes IP assignment and configuring the host name. So everyone clear, right? This the basic configuration. Everyone knows that how to configure the basic configuration. So we learn about the hardware components of the router, right? Hardware components of the router and like even internal components of the router. So then we learn about the IP addressing. IP addressing, like the IP addressing, different types of IP addresses, how many versions we have in the IP addressing, everything we learn. We'll try to post the video as well, okay, for the IP addressing. So now today in today's class we are going to discuss about a static routing. Static routing. So before jumping into the lab, right, we'll discuss few things about what is static routing, why we require static routing in the production networks. So in routing we have different types of routings, right? So in the for the very first routing is the static routing. So we'll deal about static routing, how we are going to configure the static routing. So before doing the lab directly, so this is our PPT for today's class. We'll discuss few of the points, how the static routing used to be work and what exactly the static routing. So the very first point, right, the features of the static routing is static routings are usually see so there are different types of routing. If you deal with the types of routing, we have majorly three types, like the static routing, and the second one is dynamic routing, and the third one is default routing. Again guys, in the default in the this one, like the dynamic routing, we have different types, like we have the IGP, gateway routing protocol, and we have EGP, exterior gateway routing protocol. In IGP we have like RIP, EIGRP, OSPF, IS. Here in EGP, we have only one protocol, which is nothing but BGP, Border Gateway Routing Protocol. So this is what the basic understanding about type of routing protocol. So today we are going to deal about the static routing protocol. In future, we will discuss about this protocol as well. So what exactly the static routing protocol? Let me take you. See, generally, what will happen, right? If you have an architecture, let me take the other point. So if you have two different routers, right? This is your router one, the LAN, and we have one more router 2 LAN, which is directly connected. Here we have, for example, 192.168.1.0/24 network. Here we have 192.168.2.0/24 network. It's a class C network, right? /24. It's a class C. So generally, what will happen, right? Here you are going to assign the point-to-point IP address P2P. This is our P2P link. So here you are going to take any one subnet, like for example, I'll take 172.16.1.0/32. So whereas I'll get two IP addresses, I'm going to assign here one IP address, and the other side, the foreign side, is the another IP address. See, once you configure this, all are your basic configuration. Basic configuration. So once you do the basic configuration, if you have a user here, the user one or PC1, here we have PC2, other network. Okay, this is 1.0 network, this is 2.0 network. If you have two different networks, right, once you're done with your basic configuration, when you are trying to ping here from this PC, from PC1, when you are trying to ping, like ping space 192.168.1 sorry 2.10, for example, I'm going to assign the IP address 2.10 for this PC2. What will happen, right, if you try to send some data, try to reach to this foreign PC, PC2, so you can able to reach till your gateway, and here we are going to configure 192.168.1.1/24. So your packet will reach till here, which means your router downstream interface. From there, so what router will do in the OSI model, we studied about OSI, open system interconnection. There are 7 layers, right? Consists of 7 layers. In the 7 layer OSI layers, layer 3 is your network layer, right? In the network layer, which device we are going to use? We are going to use as a L3 device, which is nothing but router. So what router used to do? So before sending the packet, right? Before sending the packet, see here, you will get source IP address is 1.10 and the destination is 2.10. So user wants to send some data from 1.10 to 2.10. So the packet will reach to this router. This router is take the decision based on the routing table. Based on the routing table. Once you've done your basic configuration, right, you will not see any routing here. See, you will see only the C, which is nothing but connected routes, and the L local routes. If you have the loopbacks, it will also show. What will happen, right? Router is going to discard your packet because in routing table we don't have a route to reach 2.0/24 network. So that's why routing is very important. So you need to configure the route towards from router 1 to router 2 as well from router 2 to router 1 to reach this particular subnet. This is what the story about the static routing. Without routing, router will not take any action, which means a router will not forward your packet from source to destination. Clear? Now, so we'll discuss about the functionalities, like the functionalities of the static routing. So how the static routing used to work, who needs to configure this, and what are the points we have. So the static routings are configured and maintained and updated by network administrator or network engineer. Network administrator or network engineer, which means, see, if we have here from router 1 LAN, if you want to reach router 2 LAN, here is one PC1. Here we have one more PC, which is PC2. So if the user PC1 user wants to reach PC2, if the PC1 user wants to reach PC2 or PC2 wants to reach PC1, so without doing the static routing, without doing any kind of routing, like we have 3 types of routing, right? Without doing routing, the packet will not be reached from source to destination. That is our first point. But if you are going to configure static routing, see, static routing, who needs to maintain this static routing? Static routing is configured and maintained and updated by the network administrator or the network engineer. Here you need to take the access of this both the devices and you need to configure the routing. That's what the point saying that. Now the second point is administrator should know the destination IP network and for configuration, which means there are router 1. See, the engineer, like the administrator of this network is XYZ. Okay, he is the engineer of this whole office. Here we have 192.168.1.0/24 subnet. In the far end side, we have another office. Here we have a LAN. In this LAN, we are going to use 192.168.2.0/24. There is a link between site 1, like router 1 to router 2. This is your other office. Here the admin is ABC. Now the point is, what the point is stating means, okay, administrator, who is the administrator of router 1, like this office, for example, we'll consider this is our Hyderabad office, this is our Bangalore office. So to configure the static route towards your Bangalore office, the administrator of Hyderabad office XYZ should know the destination network. So when you are going to configure the route from router 1 to router 2, this will become your source, and where you want to reach, that will become your destination. So the point is saying that the administrator, the XYZ, the administrator has to know the destination network to configure the static routing. When you are configuring return, like from Bangalore router to Hyderabad office, at that scenario also, the administrator ABC should know that destination network, what network is they are going to use in their LAN network. The destination network should be known. Then only the static routing configuration is possible. Else, the static routing is not possible. There is one kind of dependency, which means administrator should know the other office LAN network. This this administrator should know the Hyderabad office LAN network. The third point is administrative distance is for static routing is 1, which means AD value, administrative distance. AD stands for administrative distance. And the every routing protocol, we have different types of routing protocol. Like see, a static routing AD value is 1. RIP routing information protocol AD value is 120. Likewise, we have EIGRP. The EIGRP AD value also we have like 90 and 170. 90 for the internal routes and 170 for the external routes. Likewise, we have the OSPF as well. So OSPF AD value is 110. So every routing protocol will have a administrative distance, which means the AD value. What exactly the AD value, that we are going to learn in the next point. Okay. So AD stands for administrative distance. Is the reliability of the routing protocol. Which means if you configure, there are two routing protocols. For example, I'll take the dynamic routing protocol example. If you configure RIP and if you configure EIGRP, right? So if you configure both the routing protocols or both the routing instance on the router 1 here, so we know that the RIP AD value is 120 and the EIGRP value, if you are like trying to form the neighborship with internally, then the AD value is 90. So here we have 120 and 90. There is a tie break. Whichever the least AD value, that routes are going to propagate to router 2, not the 120 higher value, which means the administrative is the AD value is the reliability, which means trustworthiness. Whichever the value is having the low value, whichever the AD value is having the low value, that routes are going to propagate to your neighbor. That routing protocol will come into the picture for the first compared to the higher AD value. Now we should know what is the range of the AD values. So here in generally the AD value ranges starts from 0 to 255. So here AD ranges are 0 to 255. Whichever the value is less, the less administrative distance is higher priority. Which means from here router 1 to, there is a LAN behind the router 1 and there is a router 2. If you configure the static routing here and the dynamic, any of the routing protocol from the dynamic like RIP, EIGRP, OSPF, what will happen, right? The router 1 is going to like take the priority for the first static value, because the AD value of the static is 1 and the other protocols are having higher value compared to this. So the point is saying that the AD ranges will start from 0 to 255 and the administrative, whichever the AD value and whichever the administrative distance is having less, that routes are going to propagate to your neighbor, and that is a priority, like that routes will have a high priority. That route will have a high priority. So you have to remember this point, because in interview they are going to ask you, like, see, if I have configured two of the routing, any two routing instance in the same router, which routes are going to be propagate or which routes are going to be take the higher priority, then you need to say that. So as the static value AD value is 1 and the other dynamic routing protocol AD value is high, so basically it will going to prefer static route, because the AD value is less. Whichever the value is having the less, whichever the protocol AD value is having the less, so that routes are going to like propagate to your neighbor, and that routes are higher priority. For that routes giving the higher priority. Now here there is a tricky point. This point you need to focus. A static route using a exit interface has an administrative distance of 0, which means, so in static routing protocol, what we will do, right? So when you are going to configure the static routing protocol, the syntax is IP route destination network ID. We should know the destination network ID, right? And the destination subnet mask as well. Then we have two scenarios. Either we can use exit interface, or we can use the next hop IP address. So if you are trying to configure in R1, this will become your exit interface. This point will become your exit interface, and this point will become your next hop. So to reach from router 1 to router 2, who will become your next hop? This interface, irrespective of type of the interface and the number of the interface. This interface is going to become as a next hop interface. So what the point is stating here, right? So if you call the exit interface in the routing syntax, in the syntax configuration, if you take exit interface, then the distance, the AD value, the administrative distance of the static route will become 0. Sometimes I used to set, right, so from router 1 to router 2 there are there is a connectivity from router 1 to router 2. What is the administrative distance value? So whenever you see there is a point to point link, then the AD value, which means directly connected, the AD value is 0. The AD value is 0. So the point is saying that a static route using an exit interface has the administrative value is 0, as opposed that the default AD value for the static routing is 1, which means the default route, let's see, the default value AD value of the static route is, when you are going to configure from here to there, router 1 to router 2, the default AD value is 1, right? But if you are going to take exit interface, right, in the configuration command, if you are going to see here serial 1/1, serial 1/2. So if you take this interface, right, then at that time you will see the AD value will be 0. We'll do that in the lab as well. So if you have any confusion, when if you take the next hop, this is your next hop. So to reach from router 1 to router 2, who will become your next hop? This interface will become your next hop. If you use the next hop IP address, then your AD value will be 1. An exit interface is only function on a point-to-point link, which means if you are connecting from router 1 to router 2 directly, that is called as a point-to-point link, as there is a one possible next hop devices, which means from here. So this is your exit interface, and the opposite device will become the next hop router or next hop device. So these are the basic points and the basic or advanced points of the static routing. So to configure the static routing, what we required a destination network ID and the destination subnet mask. Who are going to configure the static routes? The network engineer or the network administrator has to be configured, maintain and update, right? And the AD value, the default AD value of the static routes are 1. If you are taking like IP, as we have the syntax, right, in the next slide we have the syntax, I'll tell you. So if you are taking the exit interface, then the AD value will be 0, because there is only one exit point is there to reach R2. So this is our R1, this is the only exit point we have. So that's the reason, if you are taking the exit interface, then the AD value will become 0. Clear? Any doubt till here? Silence will consider, no doubts. So let me jump into the slide 2. See guys, static routing configuration syntax. So before configuring any syntax, like any routing protocol or any interface, we should know what is the syntax. Based on the syntax, it would be easy to understand what we are going to configure and the verification command. So once we configured, we need to be verified, right? For an example, here I have a router 1. So this is my LAN network, and which is going to connect router 2. In the far end also we have a LAN. Let me take here serial 1/1, here serial 1/2. This interface, right, this is our downstream. I'm going to take FA 0/0. Here also we are going to take FA 0/0. So first we should have an idea of initial configuration, which means the basic configuration. Then we'll jump into the what is the syntax of static routing protocol. So when we are going jump into the router 1, okay, basically you will see here like this, right? So here we have a different interface. This is our upstream interface, which means this is our WAN side. You can consider this is your WAN. This is our LAN interface, right? This is our WAN interface. So if I want to configure any interface, what should I know first? First, we should have a basic the syntax. What is the syntax to configure the IP addressing on the any of the interface? The syntax is, first we need to jump into the configuration mode, then interface, type of the interface, right? Then number of the interface. Then we used to configure the IP address. IP, the syntax is address. Here we are going to assign the IP address, then the subnet mask respect to that class. By default, every physical interface is down. By default, it is admin down. So we need to use the command no shutdown to manually up the interface. Then for the easy identification, we need to configure. So where this link is going to connect, so we need to use the description as well. Description, and where it is going to connected to R2. So if you mention like this, then exit. So we'll come out from that particular interface. See here, it would be very easy, guys. We just need to have a mind to understand what exactly. When I'm going to configure this interface like this serial 1/1, so interface type of the interface is serial. The number of the interface is 1/1. Then IP address, whatever the IP we are going to use here. For example, I'll use 192.168.1.0/32. So if we are using /32 means we will get 3 IP addresses. One will go for network ID and the remaining 2 are the valid IP addresses which we are going to use here. 1.1, here 1.2. So here I'll assign 192.16.1.1 and the subnet mask /32 subnet mask is 255.255.255.252. Clear? By default, every physical interface will be in a down state, so we need to use the command no shutdown to up the interface. And here I'm going to write the description as well. It is this link that serial 1/1 is going to connect R2. So it would be easy while we are troubleshooting. So this is what the basic configuration or basic IP assignment. So once we're done with this, right? Everyone is clear, right? Till here. Guys, can I get the response from you guys? Everyone is clear till here, right? So configuration of basic IP, like basic IP and the interfaces or the host name.
Clear, man.
Okay. So now the next step is, so once we've done the basic configuration, on the both the routers, so when we try to ping from here to in this PC, whatever the PC or the server we are here in the router to LAN, so we will not able to reach because we need to do any of the routing. So today we are going to study the static routing, right? So we need to learn what static routing and how we are going to configure the static routing. So everything, guys, syntax is very important. If you know the syntax, then whatever the IP address, which class of any class, it would be easy to configure. See here. So the syntax of the configuration, there are 2 types of syntax, okay, to configure the static routing. The first command is very first command. Once you configure, see, you will be here like this router, and you are in a privilege mode. What you need to do here? You need to enter into the configuration mode. Configure terminal. So once you enter into the configure terminal, like you will see here symbol router in a bracket config. See here you can change the host name, whichever the router you are like start configuring. So I'm going to configure router 1. So I mentioned like router 1. So you will get R1 in the bracket config. Then you are going to start your basic IP assignment, right? Basic IP assignment. Once you done this, right, then you need to jump into the static configuration. To do the static configuration, we should know the syntax, how the syntax used to be. So the syntax is IP routes, okay, and the destination network ID. What would be the destination network ID and the destination subnet mask respect to that destination IP. Now here we have a 2 option. We can use the exit interface and the interface number, or we can use IP route and the destination network ID, destination subnet mask, or we can use the next hop IP address. I'll give the glimpse of knowledge here, like see, try to understand. This is my router 1, which is connected to router 2. Here I have a LAN. In router 2 also we have a LAN. Let me take the other pen so that you will get some. In this LAN, I am going to use 192.168.1.0/24. Here I am going to use 192.168.2.0/24. There are 2 different networks, okay, 1.0, 2.0. For the WAN side, I'm going to use Consider this is our serial 1/1. This is our serial 1/2. So for the LAN side, I'm going to use 172.168.1.0/32. So here I'll assign 172.16.1.1/32. Here I'm going to assign 172.16.1.2/32. So this is our topology, guys. So based on the syntax, it would be easy to configure us. Okay, we are in router 1 now. So the command is IP route. What would be the destination? So I am here. I'm in router 1. So I'll become source, right? Router 1 will become source. And what would our destination? This is our destination. We are going to configure the static route towards R2. So this is our destination address. So here we need to mention destination network ID, which means 192.168.2.0. And what is the destination subnet mask? /24, which means 255.255.255.0. Here I can call exit interface type and the number. So which means directly I can call serial 1/1. This is also right. Or else the same command, this is the second command. So IP route, destination network ID, destination subnet mask, next hop IP address. Instead of calling this interface like the exit interface, I'm going to call the next hop IP address. So when the packet is leaving from R1 to R2, so where it will be hit first to enter this network, to enter 2.0 network, it will hit here, right? So this interface will become your next hop IP address. Whatever the IP address you configured here, that will become the next hop IP address. So instead of calling this serial interface, I can mention here 172.16.1.2. That's it. Both the ways are correct. So if you are configuring exit interface, then the AD value will be 0. If you configure the based on next hop IP address, next hop IP address, the AD value will be 1. That's it. That's what the difference. Even if you configure it based on the next hop, right, the recursive route will be formed. Which route? Recursive route will form. Which means the return route will form. So once you configure towards R1 to R2 direction, R1 to R2, work is not done yet. We have to be configured from R2 to R1 direction also, from R2 to R1 as well. So this time the syntax will be written. So this is what your static routing. So to send the data from source to destination, we should have a routing, that to the static routing, because today we are learning the static routing. So we need to configure the route towards both the direction, from router 1 to router 2 and router 2 to router 1. To configure the static routing, what should we require? We require the destination network ID and along with the destination subnet mask. This is a dependency, guys. This is the dependency, because if you are working XYZ company, okay, so you are not going to say the other ABC company, right? So this is what my network ID and the subnet mask. Then where is a security? So if you are informing this, see, this will be okay if your infrastructure, both the companies are belongs to the same. For example, you can consider this is your head office and you can consider this is your branch office. Then it would be okay. But both the organizations are different. Then it would be again the security concern. Okay. So once you configure the static route, guys, to verify the static routing, these are the commands. Show IP route. So if you perform this command, right, you will see the entire routing table, which means whatever the connected routes, connected routes, as well as, which means connected IPs, and the loopback and local addresses as well. See, which means if you perform show IP route command in the router, so it will give the entire history of the routing table, like the complete history of the routing table. So instead of running this, if you want to verify only the static routing, which if you configured or not between router 1 to router 2, then the shortcut command is, if you want to see only in the the static route, the command is this show IP route static. So if you perform here show IP route static, only the static route whichever you configure towards from R1 to R2 direction, that routes are going to be propagated on your screen. This is what the syntax and the verification commands. See, every routing protocol will have advantages and disadvantages. Let's study about advantages and disadvantages as well. See, what is the advantages? Okay, it is a secure. Why it is secure? Because we are going to form the neighborship, we are going to form the routing between R1 to R2 directly. There is no other routes in between. There is no other routers in between. So it is directly pointing, secure, because it does not exchanging the routing table. So here you pre-configured what you did, right? Pre-configured. The packet will go only the pre-configured routers only, not to this. If you have like this, okay, router 3 also, if you configure static route towards R2 only, okay, so if this source is 1.10 is trying to reach destination 2.10, once the packet reaches to here, right, router 1 will send the packet to router 2 only, not to router 3, because here we already pre-configured, we fixed the routes, okay, whenever, because 1.0 subnet we have here and the 2.0 subnet is we have in a destination behind the R2. So send the packet only to R2, not to R3, because it's secure, because it will not advertise the network to other routers. It will only advertise the network to the near, like whichever the routes we configured, only that routers. And it is a reliable, which means trustworthiness, because the AD value is very less. Then the faster, it is because faster. See, the static routing is configured and maintained and updated by the who? Network engineer or administrator. Network engineer or administrators. Network engineers or administrator. So the router don't want to form the neighborship with the help of multicast or the multicasting. The router don't wants to send the router don't wants to send the like the multicasting. Instead of static routing, if you when we jump into the dynamic routing, right? Dynamic routing protocol. What will happen here? Again, we will take only two routers as an example. See here. Static routing, we need to configure manually neighborship, we need to configure the routes. Let me take this also so that you can understand very easily. See, this is a static example, okay, static routing protocol example. This is the dynamic routing protocol example. What we will do here, right, so we will pre-configure the routes from R1 to R2. We manually configure the routes, okay. Network administrator or the network engineer is manually configured. If you want to reach from 1.0/24 to 2.0/24, what will happen, right? So we here in the router 1 we pre-configured, whenever the user wants to reach 2.0, just take this path and reach to R2. R2 will take care the remaining traffic. But what will happen in the dynamic routing protocol? So to configure the static routing protocol, the network engineer or the network administrator should know, the network engineer or the network administrator should know the destination network. But in the dynamic routing protocol, what will happen, right? Whatever the IP addresses, like the directly connected interface, the self network, we just need to advertise. We just need to advertise advertise our own network. I'll log in here in the R1 and I'll start configuring. I'll introduce my WAN network here, whatever the WAN network, then I'll introduce my LAN network. That's it. And even in R2 also, we just need to introduce our WAN network and the LAN network. They both are going to form the neighborship. They both are going to form the neighborship with the help of multicast. With the help of multicast addressing. So we studied about IP addressing, right? IPv4. In IPv4, we have five classes, right? Class A, Class B, Class C, Class D, and Class C. Class A, B, C used for LAN and WAN purpose. Class D is used for multicasting. So the Class D range will start from 224.0.0.x. The range is 224 to 239, but you will see in the dynamic routing protocols, the hello messages will form. See, this guy is R1 is used to send the hello message to R2, and R2 will respond to that hello messages with the help of multicast address. The hello message will forward with the help of multicast address. Every routing protocol will have a multicast address. Then they both are going to form the neighborship. But in static routing, we are going to pre-configure. We need to predefine the routes. Okay, if you want to reach 2.0 network, just take this path, go to R2 and it will take care. So that's a reason. See here, we already pre-configured. Router need not to check again and again the same routing table. But here, what will happen, right? Due to the topology changes or something else. Okay, so if you have a router 3 here, let me change the pen, guys. If you have the router 3 here, the newly added router, which means what? The topology was changed here. So router 1 will again learn the network. Okay, whatever the LAN networks is having, what is the network behind the R2 and R3? The router will again learn and it will calculate the routing path and it will select the best routing. That all story will happen in the dynamic routing protocol. But in the static, that case is not there in the static because we pre-configured the route. That's the reason it is a false, because it need not to exchange the routing information between R1 and R2. Hope everyone clear, right? What is a static and dynamic? See, the minimal CPU and memory overhead. That's what we discussed in previous also. In static routing protocol, it's a predefined routes. We already configured from R1 to R2. So router, whenever the packet hit to the gateway, router used to check the routing table and it will forward to R2. That's it. But here we don't using much CPU, right? We don't use much CPU and memory. The process of the processing of the router, it is straightforward. Okay, whenever you want to reach 2.0 network, just use this link and go to the R2. But in dynamic routing protocol, what will happen, right? There is a route calculation will happen. In general, in every router, there are 3 different planes. First, we have a MGMT plane, then we have a control plane, then we have a data plane. So we have a 3 different planes. Whatever the routing you are going to configure, right, that will place here. Like for example, static or dynamic routing protocols, any routing protocol. So that will go here in the control plane, which means your CPU will be associated with this control plane. So CPU is nothing but the brain of the device. So everything, the route calculation, whichever become the best path, which is your the second best path, successor, who will become your successor, everything, the route calculation will happen in the control plane. But in static case, we already predefined, so that's the reason every time the calculation will not be happen. So that's the reason we are not going to use the much CPU and memory of the router or switches, any L3 device. No wastage of the bandwidth, that's what here. So we need not to send the hello messages every time to form the neighborship. Likewise in the dynamic routing protocol, they used to form the neighborship with the help of hello messages. But in the static, the hello message scene is not there. So that's the reason updates are not shared between the routers. We already pre-configured. And the main thing is static routes are going to configure are used in the small networks or the small organization only. You will see the static routes even in the data center, but how you are going to see, right? Consider this is your core switch. Here we have a access switch 1. Here I have a access switch 2. From here to there, I used to configure the static routing because I don't want to run the dynamic routing protocol. I don't want to waste my bandwidth. So to the point, whatever the traffic you are getting, this switch 1 is getting, I simply, with the help of static route, I used to send to the core switch. From in the aggregation layer, right? In the core layer, we can call as a core layer. So here we have a router, firewall, other devices. Here we used to run the dynamic routing protocol. Then the routing decision will be happen. But from access to core, to send the traffic from access node to the core node, we use it even in the data center also, static routing protocol, because we don't want to bother the device much more. And it's a granular control on how traffic is routed, which means, so here we are going to predefine and we have a control in our hand. So if you want to reach the R2 LAN, instead of going R3, here if you take R3, I can configure the static route towards R2 because I need to reach from this LAN network to R2's behind LAN network. I don't want to go via like this. Okay, I can go directly, which means I have the network engineer or the network administrator is having the control on his hand how the traffic has to be flow. He'll decide. So that is what the advantages. We can consider these are the advantages of the static routing protocol. When we jump into the disadvantage of the dynamic routing protocols are no automatic updates. See, automatic updates, which means if you run any of the dynamic routing protocol in the router, dynamic routing protocol. So we have a different dynamic routing protocols like RIP, EIGRP, OSPF. So every routing protocol will have a like hello hello timer, like hello timer and the dead timer, hello timer and dead timer. So based on this timer, every time router one, if I run between router one to router two, the dynamic routing protocol, every time router one used to send the hello messages, and router two will also send the hello messages. So this messages, the hello message, based on this hello messages, only they are going to form the neighborship. This dynamic routing protocols. Okay. So, but in the static routing protocol, we don't have a that hello messages scheme. So here in the dynamic routing protocol, we have the hello messages and the dead messages, which means the router one and router two, before forming the neighborship, they used to share the hello messages with the help of multicast address. But in the static routing, we don't have that case. No update, no automatic updates. Okay. And the one more disadvantages is network engineer or the network administrator should know the destination network ID to configure the static routing that we saw already, right? So whenever you want to configure the static route, the network administrator or the engineer should know the destination network ID, and the administrative work is more. See, in my network, I have two routers only. In my network, I have two routers. Is it okay? Yeah, I can configure the static routing protocol here, like because okay, it is acceptable as the company is going to pay me to work as a network engineer. So I can configure the static routing protocol in two routers. So if I have 100 routers, how is it going to work for the static routing? It would be difficult because there is a more administrative work. So if you have a router, like we need to like configure the each and every router. We need to configure each and every router to static routing. That would be difficult, and infrastructure changes must be manually adjust, which means there is a router one and router two. Again, my company has suggested Kalim take one more router. Okay, take one more router. So we take one more router because we have a redundant path now to reach particular destination from R1 to R2. I can go. This is my primary path. Wherever this path goes down, so I can go like this. So whenever there is a changes in the topology, then again we need to do the manual configuration. The auto neighborship will not be case here in this static routing. And the no dynamic fault tolerance, that's what. So actually router 1 to router 2, this is the way the primary route. If it is goes down, it will not take by default the secondary route. It will not. In the static route, it will not take. So to configure, to take that, we need to configure the floating static route. Again, in the last slide, I already mentioned that floating static routes. We need to configure the floating static routes, which means floats. See here. Okay, this is our floats. Everyone visited sea, right? Beaches or somewhere else. So which means what? If everything is working fine, take this route. If this route goes down, take this route. That's what the meaning of floating static route. There will be one primary route to the destination. If that route goes down, so we used to configure the floating static route with the higher administrative value. So if the lower administrative value route is not available, then it is going to take the next uh, higher AD value route. That we'll see practically in our next slides. So the static routing is impractical in the large networks. That's what I mentioned here. So this is what the advantages and disadvantages of the static routing protocol. So everyone is clear till here, right? Any doubts? Just let me know, guys. Any response? 18, 11, 15 only. All are sleeping.
No, bhai, clear, bhai.
Clear. Okay.
Yeah.
See, we are studying about the static route, right? static routing. So how many types of static routing we can configure? In routing, generally we have like static routing, default routing, and dynamic routing. We know this. There are three types of routings: static routing, dynamic routing, and default routing. In static routing, see here, this is a standard static routing, which means what we used to do every time. That is what it is. Normal static routes are implemented when connecting to the a remote network, which means R1 is here, which is going to connect my remote network to the other office. I can consider this is my Hyderabad office and this is my Bangalore office router. In between both the routers, we are going to configure the static routing protocol. So this is what the normal procedure that we discussed. Now we have one more, a default static router. Default static route. A static route with the 0.0.0, which means anything, any IP, any subnet, which means unknown destination. Generally, how we can consider this, right? In the organization, what will happen in the organization, in the live production network, we have a ISP, internet service provider. Okay, if every time we know that from the basics of our networking, whenever the router is used to send the packet from one location to other location, what router will do? Router used to check its routing table, right? Its routing table. So in the routing table, there will be one route in the least, okay, least of the routing table in the last, that is nothing but static default route. Okay, static default route, or we can call as a default route, default default route. What will happen here, right? If anything is not matched, we know that router is when the router is used to send the packet from source to destination, every time router used to check the routing table. If there is no route match, if there is no route match for the particular destination, then the router is to choose the default route, which means 0.0.0.0/0. Any IP, any subnet, if it is not reached, right, take the internet way and send that. Because over the internet we have a different servers, different services. We have a Google DNS also. Google DNS. Just I'm considering Google DNS example because the easy perspective. The IP address is 8.8.8. In router, right, in the organization router, we will not have a route to reach this. We will not do any routing to reach this one. So with the help of default route, if any route is not matched to reach Google DNS, just take the default route and move the traffic over the internet. So that's the reason we are going to use default route, default static route. And the other types of static routes are summary static route or floating static route. That's what we discussed, right? The floating static route example is, let me draw here, router 1. Consider this is my ISP 1, this is my ISP 2, here is my LAN. I have two connectivity. This is my primary, this is my secondary link, which means whenever the user try to browse the internet, okay, every time the traffic hit to gateway, from gateway it will take this way and it will go to over the internet. What happened if the primary route goes down? If the primary route goes down, then the secondary route will serve the user traffic and it will become the primary. It will become the primary, and the traffic used to go like this from the secondary route. Because if we are going to configure, right, see, I'll show you how to configure IP route, destination network ID, and the destination mask or subnet mask. I'll take here the next hop IP address, next hop IP address. This is our general normal static route. So for the primary route, I'm going to configure like this. For the secondary route, what we will do, right? IP route, destination network ID, destination subnet mask, the next hop IP address, next hop IP address. Here we are going to give some value. Okay. Instead of leaving like this, we are going to here giving 10, which means what is the default value, AD value, the whichever the primary route, the default AD value is 1, and this secondary route AD value is 10. So if the primary route the primary route AD value is 1, right? The primary route goes down, then router will check the routing table. Then what is the next AD value? What is the next trustworthiness? So this is a trusty route. So the router used to send the traffic from the secondary link. That is called floating static route. Wherever it is up, okay, the primary route traffic used to send from the primary route. If this is going down, then the secondary route will consider as a primary route, because this is the next AD value, next trustworthiness. This will become the primary route, and this is called as a floating static routes. Floating static routes are generally used to configure towards your internet side, okay, because if you have a primary route, if that goes down, then the secondary route will become the primary route. So this is what the theory about the static route, guys. So even if you take this topology, right, see, generally we used to configure to reach from this is my source, this is my source, and this is my destination. 2.0 20.0 is my destination. So to reach this destination, I'll send the packet like this, okay, and it will go to the NEP user. This is a normal behavior, right? So even we can configure based on the asymmetric routing. Asymmetric routing, which means the ICMP, if I try to ping from here, right? Ping from here, okay, we'll do one thing. We'll assign this PC IP address is 192.168.10.100, and the subnet is /24. Here I am going to configure 10.1. So gateway will become 192.168.10.1, right? So here also we have a 20.0 network. So any of the PC we are going to assign 192.168.20.100, and the subnet is /24. Gateway will become 192.168.20.1. So here we are going to configure 20.1. See, now what will happen? What is exactly asymmetric routing? So when I try to ping from here, right, from this PC 1.100 to source is 1.100, the destination is 2.100. Ping means what? ICMP traffic, right? So in ICMP we have ICMP request and ICMP reply. ICMP request and ICMP reply. So I can configure in this manner, like whenever the ICMP request is going, you can take this path to reach this particular PC. If the reply is coming, you can take this path. That is called asymmetric routing, which means जिस रास्ते से तुम जाते हो दूसरे रास्ते से अंदर आते हो उसको बोलते हैं asymmetric routing. So we can do like this also in the static routing. Clear? Any doubt till here in the asymmetric routing part? Guys, unmute. Any doubts? कौन बचाए तुमको? अल्लाह ही बचाए. See, this is what the topology I just prepared to do the lab, but uh, considering the time is like 11:30, around 11:30. I know that everyone is sleeping, so that's a reason. I'll share this. I'll share this topology with you guys. Okay, try to practice how to do the static routing. We already done. We know the syntax, right? We know the syntax how to do the static routing. So this is our static routing topology. Static routing topology. So you can practice this. Okay, if you are going to configure here in the R1, we are going to configure in the R1, this interface will become your exit interface, and this interface will become your next hop interface, next hop IP address. If you configure in this direction, this will become the exit, this will become the next hop, the same way. So everyone, tomorrow try to practice this topology. If you want, I can take one more class for this, for the lab parts lab. Okay, So we can configure, you can configure this. So here I'm going to take in this office, in the Hyderabad office, I'm going to take 1.0 network. In the Bangalore office, I'm taking 2.0. In the Chennai office, I'm taking 3.0. So everyone from, like, from here, from this source to, if you try to reach from here, it has to be reached. So once you configure the static routing, and it has to be reached here also. So vice versa. So this is one topology, and another topology is this. So for the asymmetric routing purpose, or the load balancing, you can call as a load balancing also, because we parallelly we are having two interfaces, right? So we are going to use this interface and this interface also. So here you can configure the same thing. Clear, guys? This is also the static one only. Try to do the lab, okay? If you have any other doubts, just connect with me and I can clarify. The same subnets I have taken here also. Here I'm taking for the WAN side /32, which means we will get 3 IP addresses. We can assign 1.1 here, 1.2 here, again 1.1 here, 1.2 here, 1.1, 1.2. It would be easy, guys. You can just try to practice once, okay? If you have any other doubts, just let me know. Any doubts?
Clear, man.
Clear, Akram? Okay. Others?
Clear.
Okay.
Clear, bhaiya.
Okay, guys, let me stop the recording.